welcome to 9.2 Swyk number 1. All right, we're dealing with inverse variation, and eventually we're going to get to combined variation. But let's deal with the inverse variation stuff first. So first thing I see in this problem, suppose that x and y vary inversely. So what they just told me was this. Y equals k over x. Remember, they don't mention k. You have to remember that. And then they tell me this. X equals 1 when y equals 10. Why do you think they gave that to me? They gave that to me so I could figure out what k is. Plug them in. Obviously, that's not too tough, right? Okay, k is 10. They wanted me to write the equation, y equals 10 over x. Y equals 10 over x. Now, I want you to notice in the next part where they're graphing that they only specifically chose quadrant 1. They are not looking at quadrants. This actually would be in quadrant 3 also if you take all of the graph. But they're specifically looking at quadrant 1. A lot of times we do that because we're talking about story problems. When we talk about story problems, we say, okay, we've got 100 cars to wash. And if we have one kid wash all 100 cars, it's going to take X amount of time. But if we have 50 kids come out to wash cars, it's going to take this amount of time. So we do that with story problems because we're dealing with positive numbers most of the time. So that's why, whoops, that ain't what I wanted to do. I wanted to move the whole thing. Okay, so here's what's going on. It's either going to be the first one on the far left or the last one. Those are the only two that have what's called an inverse shape to them. They start out high and then they come down low. Okay? The other two are linear. They don't even make sense for this situation, right? Those are actually direct variation, right? These are both direct variation, and we're clearly dealing with inverse. Now, the next thing, so how do I choose between them? I need a coordinate. So let's make it easy. I plug in a 10. If I plug in a 10, I get 1. So let's take the coordinate 10, 1. Now, and if I do that, if you look at the first one, remember that everything goes by 2s. So this is 10 and this is, wait a second, that's, oh my goodness, I misread the graph. I chose the wrong one because I wasn't paying attention to the scale. I did on the x-axis, but I didn't on the y-axis because this is actually 10, 1, which is the correct. Oh boy, man. Better not. That is ridiculous. How in the world could I have missed the scale on that? Gee whiz. Right here's 10, 1. Why isn't it writing? Oh, because I'm not drawing. Why isn't it? Okay, there it is. Okay. 10, 1 is right there, and it's not on the graph. So, daggone it, get rid of that circled one. That ain't it. Okay. Glad I saw that. Okay. Now it says find y when x is 20. Find y when x is 20. Well, so I went to my equation. 10 over x. I plugged in the 20, and obviously I reduced it to get 1/2. They want integer. Ooh, wait a second. Integer or decimal. Fraction ain't allowed. It'll count you wrong. You want 0.5. 2 mistakes in the same question. Man, I would tell you this. You know, some kids ask me, when am I ever going to use this in my life? Okay, here's the answer. Some of this you're never going to use in your life. That's the dead honest truth. What are you going to use? In every math class you've ever been in, one of the most important things is finding mistakes. Because every single person on the planet should be looking for those mistakes to fix. Whatever job you have, you need to find mistakes before they become major problems and either cost your company money, cost you your job, those kind of things. Find the mistakes. The other thing is logic, following logical progressions, because every job has logic. But you're right, I understand. Some of this you're never going to use. But the skills that we're building in you, you will all use if you're paying attention. So the next part says we've got inverse variation. So that gave me this information. They gave me a coordinate. Obviously, they wanted me to plug it in to find the K value, which is 28. That's all they were interested in. Next question. The bake sale. We've got the number of muffins and the sales. Notice that as X is getting bigger, Y is getting bigger. That's not inverse variation. That's direct variation. What's it doing in the middle of an inverse variation section? I don't know. But it's a cool problem anyway. So, helps me review, I guess. So, the sales equals K times M, right? The constant times the number of muffins. If we plug in a coordinate like 9 and 2250, we find out that the K value is 2.5. So, our equation is sales equals 2.5 times each muffin. And that's why we put that in this box. They already had the S equals, so we didn't need to worry about it. Then they asked me, well, if you sell $250 worth, how many muffins did you sell? We need to sell at least 100 muffins to make $250. All we did was plug in the 250 in the correct spot and divide. Not real tough. You guys are good at that stuff. Question 4. Another direct variation? Smack dab in the middle? Okay. All right, so we got y equals kx. We're plugging in the 3, 8. Right? Here, let me zoom in on this. Plugging in the 3 and the 8, finding out that the k value is 8/3. Then it says find the missing value, so they give me an x value of 18. Multiplied together, we get 48. Now, I'm going to show you a second way to handle this problem, but I really do like this way because you have to find the constant of variation. In the next way, you kind of ignore the constant of variation. You're still doing it, but some of you might have asked or thought about doing this. If you take the y over the x, because we know that the k equals y over x, it's the same number every single time you do y divided by x. That's why it's called a constant. You should be able to set up a proportion and just solve it. And that's true, you can. But if that becomes like y equals x squared, you got to be careful with it because you could easily, get the wrong answer if you're not doing that correctly. So I would suggest you stick to a method like this. Question 5. Each pair of points on the graph is an inverse variation. All right. So y equals k over x. Plugging in the 4.5 and the 10. And then multiply together and get 45. And then they give me a new value, but this time they give me the value of y. Now, here's a little trick I don't know if you know. Did you know that you can take the numerator on one side of a proportion and switch it with the denominator on the other side? So literally the 5 and the x can swap places. It's a property of proportions. They should have taught you in middle school. If they didn't, shame on them. If I do it, it's not going to hurt anything, and I get x equals 45 over 5, which is 9. Now, that is the way I would like to see you work it out, but we could do that since the constant, right, k equals x times y for inverse variation. Another version of that would be to set up x times y on both sides. 4.5 times 10 equals x times 5. And of course, to solve that, you would divide by 5. And you're still going to get 9. Same thing you got before. I don't recommend that way just because people, if you understand what you're doing, great, go ahead. But really, you need to be able to write the inverse variation equations, find the constant variation. So this way is my favorite way. I think we're done with this Swyk. Oops. Hey, let's find a joke for you for today. A joke for you today. Let's go with, why was the DJ banned from the supermarket? He was stealing all the samples. Did you hear about the guy who invented Altoids? He made a mint. Some kids didn't get the idea when I told that joke earlier this morning that a mint is a lot of money. And it's an Altoid. Okay, never mind. Moving on. I won an award for being the best scarecrow in my field. I told them, hey, it's in the genes. All right. Thank you very much for listening to my fantastic dad jokes, and I'll be with you on the next Swyk.